Hello everyone, I hope you're doing well. Today I'm going to introduce you to programming in Unreal Engine within the context of making a virtual reality project. In this example, I will be making a door which opens once the user completes a little puzzle. For simplicity's sake, I'm using the GDXR VR template, which includes a lot of basic VR features. However, these principles will largely apply to Unreal's basic VR template as well. This will be our first foray into programming in VR, so we'll try to take it slow, but we're going to try and cover a lot of bases to really get the ball rolling for you. So to get started, I'm going to open up my content drawer by clicking here in the bottom left, and I'm just going to dock it in layout. And the first thing I want to do is create a blueprint class. Now, what is a blueprint class? A blueprint is simply an asset which can contain functionality. If you're familiar with programming in other languages, then a blueprint is just another word for a class in object-based programming. So to create a blueprint, in my content browser, I'm going to right click and I'm going to go up here to blueprint class. And here I have a couple options for what kind of blueprint I want to create. I'm going to go ahead and create an actor, which is essentially a blueprint which can be placed or spawned in the world. I'm going to call this blueprint BP_test. It's a good practice to name all of your blueprints with the prefix BP_whatever, just so that they're easy to find when you are searching for them. And then I'm just going to double click this to bring up this menu. This is the blueprint editor where we can add components and functionality to our blueprints. In the center, we have our viewport where we can see what our blueprint looks like. And there's not much to look at right now, though, because there is only a root component and nothing else attached to this blueprint. So if I want to add more parts to this blueprint, I can go up to here and press add. And then I can go down here to cube to add a cube to this blueprint. When I want to confirm any changes that I've made to a blueprint, I can go up here to compile. And compiling just means that Unreal goes through and looks through all your code and makes sure that everything is working correctly. If there's any errors, Unreal will tell you, and this compile button will turn red after you hit compile. If there's any changes that are uncompiled, it will be yellow. And then if everything is good to go, it'll be green like this. This is different from saving, which will actually commit your changes to your file for this blueprint. So keep in mind that compile and save are different. So now that I've added a cube to this blueprint, I can go ahead and move this aside and then drag my blueprint into the world. And there's my blueprint with the cube. I'll even drag in another one. You see that they're both identical. And then if I go back into the blueprint and make changes, those changes will be passed along to the instances of this blueprint in the world. So say I'm going to go to add. This time I'm going to add a point light. I'm going to drag it up. In the details panel, I can make my light red. Maybe make the distance that the light spreads a little shorter by changing the attenuation radius. And I'll compile. And now we can see on each of these cubes, there's now a point light above each of them. So that's how blueprints work in short. I'm going to go ahead and delete these cubes because I don't want them. And I'll close this. Next, I want to go ahead and make a door. So I'm going to create a blueprint class, actor again, BP_door. And I'm going to open that up. And the first thing I want to do is add a door model to this. So I'm going to go to add. I'm going to select static mesh. A static mesh is just a 3D model. I'm going to call this door mesh. Enter. I don't see anything right now because I haven't chosen a mesh to attach to it. So I'm going to go over here to the details panel. And under static mesh, in the dropdown, I'm going to find my door. And I can just type door here to jump right to it. Door 06. Any door model will do. This is just the one that I found. It looks a little plain with this material, so I'm just going to add a material I made ahead of time. Search for wood and apply that to the door. And compile. And then if I drag my door into the scene, I can place it right in here. like so. I'm going to try and line it up with this door frame. Excellent. Now that I've got my door in the scene, let's start adding some functionality. So I'm going to bring this back up. And while right now we're in the viewport, I can go over to this tab to switch to the event graph. Now, the event graph is essentially a node-based graph editor, which uses events and function calls to perform actions in response to events associated with that blueprint. In other words, this is where you add functionality to your blueprints, both in terms of what this blueprint can do and how it can respond to events. So for this example, we're going to tell this door to rotate into an open position when it receives a specific event telling it to open. I'm going to make this a little bigger. To navigate in node editors in Unreal, all you need to do is hold right click to move around and use the scroll wheel to zoom in and out. Next, let's talk about events. And before I make any events, I'm going to delete these preset events that are left for me whenever I make a new blueprint. And then I'm going to right click once and it gives me the search bar where I can search for new events. So I'm going to look for the begin play event. Hit enter, and now I have an event. Next, I'm going to go ahead and attach a node to this. So I'm going to drag off from this pin right here, release, and it gives me another search bar. And I'm going to look for a node called print string. So what are these two? While they're both nodes, it's important to note that red nodes are called events. And when an event is triggered for one reason or another, an event will send a signal down the line to all the nodes connected to it in order from left to right. Typically, an event's name will clue you into what its trigger is. So, for example, this node is titled Event Begin Play. That means it will be triggered as soon as we begin playing the experience. Meanwhile, on the right, we have this node labeled Print String. And what this does is it simply prints a message. So by default, it says hello, and it'll add hello world. So what this means is when the experience starts, my door will immediately print the message hello world. And we can test this out if we go up here. And I'm not going to turn this on in VR yet. I'm going to go over here to the three dots and select simulate. So I don't have to put the headset on. I can just see what the world does when I start it. So hit simulate, and right here in the corner, I don't know if you can see it, it's at hello world. I want to do it again. Let's make this longer. Make it 10 seconds. I'll close this up. Hello world. Now let's say I wanted it to say hello world, but I didn't want it to happen immediately. Well, I can pull this back up and I can add a new node between event begin play and print string. And this will be a delay node. And what a delay node is it simply adds a timed hold in the order of events. So if I say the duration is 2, it'll wait 2 seconds before moving on to the next node in the line. I'll compile, save, and it'll simulate. 1, 2. Hello world. So delay nodes are really useful for adjusting timings of things. Now let's say I might have a situation where I want to have a bunch of different doors and each one has a different length of a delay before it actually opens. Well, to do this, I would need to take advantage of variables. Now, variables are just properties that hold a value or a reference to an object or actor in the world. So to add a variable to our blueprint, all I need to do is go over here on the left under the variables tab. I'll hit the plus sign to make a new variable. There are practically countless types of variables, but you'll usually only be working with a handful of them. So just to give a couple of examples, let's run through a few. The first one is a Boolean. And Boolean is as simple as a true or false value. That's all it stores. So I could have this variable here be open. And that variable is simply representative of whether or not the door is opened or closed. I'm going to go ahead and make another variable. Let's go down the line. So an integer is a number. And specifically, it is a whole number, which means it can't be divided into decimals. This is compared to a float, which is a decimal number, which means it can be neatly divided into fractions. Below that, there's name, string, and text. All of these are variables which hold text in slightly different ways. And most commonly, you'll be using string, which happens to be what print string is using. Then a little further down, you'll find vector, which is essentially a compound of 3 floats. So it is 3 decimal numbers packaged together. And vector is often used for things like location data, because if you need to save a location, since we're working in 3 dimensions and everything is on a X, Y, and Z point in the world. Rotator is very similar in that it is another compound of 3 floats, but it's specifically used for things that deal with rotation. And then transform is another compound which contains 2 vectors, one for translation and one for 3D scale, as well as a rotator for rotation, meaning it's essentially 9 floats contained in one variable. Now, those all hold values, but I mentioned that variables can also hold references to objects and actors. So one of those would look like, if I open up object types, I can find actor. And from there, I can make an actor object reference. And we'll get into that a little bit later, but all that means is that you can have this blueprint remember another blueprint and refer to it later. But I'm going to make this a float for now because I want to have this be my duration. And now to use this float, all I need to do is click and drag it into my event graph. And it gives me an option to either get duration or set duration. Get duration is basically a reference to that variable. So if I get the duration and then I plug it into the delay, now my delay will be based on my duration variable. And then I can set this duration variable by hitting compile. And with it selected, I can now go over here in the details panel and set a new number. So I'm going to set this to 1. And I'll hit compile again. Now, I said I wanted to do this so that I could set this variable on different doors. And there's one more step I need to do before I can do that. Variables by default are what's considered private, which means that they can't be accessed in this editor. So if I click on this door, there's nothing I can do here to change that variable for this individual door. But if I go down here and I click this little closed eyeball, it opens up and it's now considered to be a public variable. I'll hit compile to confirm it. And now what that means, if I have this door clicked in the details panel here in my level editor, I now have the option to change the duration. So I can set this to 1.5. And it's still different from the default value here of 1. So that was a lot of groundwork to cover. Let's put this into action. So I want this door, when the level starts, to open. So I need to basically tell it to rotate. To do that, I'm going to add another node, and this is going to be a set relative rotation node. I'm going to select this one with the door mesh in parentheses, and it's automatically created a reference to my door mesh. Notice that this looks just like my duration node here. So components within my blueprint can also be referenced as variables. And now in this node, I want to set the Z rotation of this door to 90. I compile and we'll simulate. And after 1.5 seconds, the door rotates. Though there's a couple things wrong with it. I didn't want it to rotate in the center, and I didn't want it to rotate immediately. So there's a few more steps we need to do to make it a clean, natural opening animation. The first thing we want to do is to add a pivot so that this door rotates on the hinges and not from the center. So I'm going to go to my viewport again, and I'm going to select my default scene route. And a scene component is just a component that contains a location. So by this component being the top in the hierarchy here, it's essentially acting as the location origin of the entire blueprint. Now I want to add another one of these scene components to my blueprint to act as a pivot point for my door. So I'm going to go to add. I'm going to go down to scene. I'm going to rename this to door pivot. And I'm just going to slide this over to the very corner. Make sure it's really close. Right there. I compile and save. I'm going to go back to my event graph. And I'm going to replace the door mesh reference by just selecting it and hitting delete. I'm going to go to door pivot, drop that in, and connect it to the target of set relative rotation. And then finally, I'm going to make sure that door mesh is a child of door pivot. Work my viewport, make sure that nothing is messed up. Everything looks fine. Let's go ahead and simulate. And there we go. My door opened like I would expect it to. But it's still snapping from one position to another, so let's add some animation here. And to do that, I'm going to go to event graph. I'm going to maximize this. I'm going to go ahead and delete my string component. Move aside, set relative rotation. And from delay, I'm going to add a timeline node. And every timeline is going to store data, so I want to give this a unique name. I'm going to call this open door timeline. And enter. And then I'm going to double click it to open up the timeline. From here, I can add a track. We're going to add a float track because we want to be changing a float value, in other words, a decimal value, over time. I'm going to give this track a name and call it door rotation. Once I've done that, I can right click in the timeline to add a key. And I'm going to do this twice to add two keys. With the first selected, I can then set a time. I'm going to set this to 0 to put it at the beginning of the timeline. And I'm going to set the value to 0. And then the next one, I'm going to set this point to 1 in the timeline. And set the value to 1 as well. And then up here at the top of the track, I'm going to set the length. And I'm going to set it from 5 seconds to 1 second so that the timeline ends at the second point. Then finally, I'm going to select both of these points and right click. From here, I can change the interpolation mode. So by default, we just have a linear interpolation. So it will move from 0 to 1 along the timeline at a completely even pace. Whereas what we want is to have auto tangents. And basically what that means is that we'll ease in and out of this animation. So it'll make it look a lot more smooth and less robotic and programmy to have automatic tangents. Now, every frame that the timeline moves along from 0 to 1, it will update this door rotation to match this point in the timeline. So at 0.5 seconds, the value of door rotation will be 0.5. Once I've done all that, I can close this tab and go back to the event graph. Then afterwards, I can go ahead and attach this to my relative rotation. Now, there are two pins to drag off from here, update and finished. The update pin will send a signal down the line every single frame that this is running for. Whereas the finish tab, and I'll just make another print string here. So that finish tab will fire once the timeline is done. So at the end of 1 second, it will fire the finished event. Now let's type in door opened. And then I want to attach this output, door rotation, to my relative rotation inputs. But there's a problem here because this is a float and this is a rotator. But if you remember, rotators are just a compound of floats, and we can actually access each of those by right-clicking and selecting split struct pin. And basically it breaks up the rotator into 3 floats. And one more step before I plug this in. If you remember in the timeline, I set it to only go from 0 to 1. So I want to actually multiply that number so I can get to 90 like before. So to do that, I'm going to drag out from here, and I'm just going to type in multiply and enter. And what that's done is it's given me a math node to multiply this float by. So I'll set the second input to 90 and plug that into the rotation Z. And now whatever number door rotation is at, it'll always be multiplied by 90 until we get to 1, and the result is just 90. Next up, I want to use a branch node to determine whether the timeline will play forwards, causing the door to open, or will it play in reverse, causing the door to close. So I'm going to drag it from here, branch. And the way branch works is it takes in a Boolean as an input. And again, a Boolean is just a true or false value. And then depending on that condition, it will fire an event down either the true or false pins. So I'm going to grab a reference to my open variable. I'm going to attach it to condition. And now the branch node is referencing this open variable. And right now open is set to true. So it will fire the true node and hit play. And as before, when we simulate, the door will open. But let's say false goes to reverse from end. And then I will set my open value to false, meaning the door is supposed to close. Hit compile. Simulate. And the door plays the animation from the end in reverse. Now that's a bit unnatural, so instead I'm going to set this to reverse, which means it won't jump to the end of the animation. If it compile and simulate, nothing happens because it's playing the animation in reverse, but it's already starting from the beginning. Later on, we'll set up a way for the door to open and close, but for now we'll just set open to open by default. Now we don't actually want the door to open at the beginning, so I'm going to go ahead and delete begin play and compile and save. And now there's one final thing I want to do to this door mesh, and I'll need to demonstrate this in VR. So I'm going to turn on VR preview. Now in VR, I can teleport by pushing forward on my right thumbstick. And while I can't teleport through the walls, I can teleport through the door. And that's a problem if I want to make a puzzle where the goal is to open the door, not teleport through it. So all I need to do is go to my door mesh, select the component, and over here in the details panel, I need to scroll down until I get to the collision tab. And from here, I need to set my collision preset away from block all dynamic to custom so that I can define this object type as a world static. And without getting into the gritty details, all that means is that world static will block the teleporting line trace from phasing through the door, making it so that you can't teleport through it. And then going down to 3D widget and making sure that's set to block, as well as hand collision and world climbable. So making sure to block absolutely everything. And then once I go into VR, I can try to teleport through it, but my attempts are thwarted. So now that we've made a door, let's go ahead and make a few more blueprints so that we can start to make a bit of a puzzle to open it with. So to do that, I'm going to make 3 more blueprint actors. This will be a ball, so I'll call it BP ball. I'll also make a pipe which opens the door once a ball is dropped in it. So it'll be called BP goal pipe. And then I need a pipe which spawns a ball. So this will be BP spawner. And then also there is a button actor which I have already added to the scene that comes natively with the GDXR template. I've just added this for simplicity's sake, since creating a physical push-down button like this from scratch would be a whole complicated process in itself, and there's already enough going on in this lesson as it is. Instead, this will be a good opportunity to show how to implement a third-party template object such as this with your own custom blueprints. Now, one last goal pipe. That I made before starting this video. I'm going to right click and I'm going to go right here under blueprint and go down here to blueprint interface. And I'm going to call this BPI underscore door functionality. And then I'm going to double click that to open it up. So what is a blueprint interface? A blueprint interface is a collection of one or more functions that can be added to other blueprints. And by using these functions, blueprint interfaces allow different blueprints to share and send data to one another. So I can make basically a custom event, which I can then trigger in one blueprint and it gets sent to another blueprint to execute. So when I made the blueprint interface, it already gave me a function just called new function. I am going to rename this to door swing. And I'm calling it door swing because I want to leave open the possibility to maybe have it be a function that opens or closes a door. And then when you make one of these, you can also add inputs, which are variables. So I can give it a Boolean and call this open. And if I wanted to, I could set a default value and I will go ahead and make that true. And once I'm done, I'm gonna hit compile. And of course, save. Then jumping back to the door. So to use this blueprint interface I just made, I first need to go to class settings right up here at the top. And I need to go down here to interfaces and specifically implemented interfaces. And from here, I can select this drop down. I'm going to search for my door functionality. And once I have selected that, I should see BPI door functionality right there. I'm going to hit compile. And now that I've done that, my blueprint has inherited all of the functions from the BPI, of which there's only one right now, but I could fill this up with dozens if I'd wanted to. So in my door, I'm then going to search for door swing. And there it is, event door swing. I'm just going to drag that up here. Plug that into my delay. And see, because we added that input of a Boolean, that Boolean now becomes an output for the event. So I'm going to give myself a little more room here. And I want to have it so that when this event gets called, first it sets the open variable. So I'm going to drag open into my event graph, and this time I'm going to select set. And what that means is anytime this node gets called, it will set the variable to a new value. So if I put this in here, connect the node in between the event and duration, and then drag the open output over here to the set node. Now, whatever value comes in through this event will set my open variable, which means if this comes in with a value of false, then by the time it gets to my branch, open will be false and it will play the reverse animation. Then hit compile and save. And that's enough of the door. Let's move on to the goal. So from here, I'm going to add a static mesh. I'm going to make this a pipe. I'm going to go to the static mesh drop down in the details panel and search for pipe. Here it is. I'm going to give it a material. I already made a material ahead of time called gold pipe to make it a nice yellow, so it stands out as something you want to look at. And then next up, I want to add a component called a collider. So we go to add. I want this to be a sphere collider. Let's call it collider. And what a collider is it's basically a component which is invisible, but it can either block other objects from entering inside of it, or it can detect when other objects enter it. So if I slide this up here, and I think I'll make the radius a little bit smaller. So over here in the details panel, I can set this to maybe 28. Kind of want to put it at the bottom here. And then when you're working with colliders, it's important to pay close attention to the collisions. So I'm going to go here and set a custom preset. And I want to just make sure that everything here is set to overlap. So one thing was set to block and one thing was set to ignore. So with that, now it will make sure to register everything as an overlapping event. Then once I've done that, I want to scroll down all the way to the bottom. There's a category here called events. From here, I can add events to my event graph that are all associated with this collider. So the one I want to find here is on component begin overlap. It's the second one down. And this event fires every time something overlaps with the collider. So when that happens, I want it to activate door swing. And this time it's a message. So it'll activate the door swing event on any object I specify as the target of this message. Now, how do I go about that? Remember earlier how we talked about variables can hold references to other objects? That's what we're going to do here. So I'm going to go down to variables, make a new one. I'm going to call this door ref. And under the type, I'm going to open up object types and select actor. Make sure it's an object reference. And then I'm going to go ahead and make this a public variable and hit compile. And see the compile button turned red. That means there was an error. It's important to note that when you get compile errors like that, Unreal will not run your software until you fix that compile error. Now, see, I forgot to add that reference as a target. So I'm going to drag door reference out. I'm going to get it, put it as a target, and hit compile again. And now it's happy. And then out here, I'm going to drag my pipe into the world. Put it right there. And then in the details panel on this instance of the pipe, right here, I have the option to set a reference. And using the eyedropper, I can select anything in the scene. So I'll select the door, and then it appears right here under door reference. So now in my event graph, this pipe will know exactly what door to send this door swing message to. Now, we don't want this event to activate anytime just anything enters the pipe. We want to make sure it's specifically the ball. So to do that, we need to check that whatever actor enters it is of the class BP ball. So to do that, first I need to get the class of the other actor. So I'm going to drag it from here. And I'm just going to type get class. And this little node will basically take whatever object it gets and find out what type of object that is. So this could be any individual object, but this will spit out what classification of object that is. What kind of blueprint did it come from? And then I want to make sure that that equals the ball object. So I'm going to type two equal signs to get equal. And in programming, typically, two equal signs basically means it is checking whether something is the same as something else. Whereas one equal sign usually means you are setting something to something else. But I digress. Once you have this node, go ahead and go to the dropdown and enter BP underscore ball to specify that you want to check to make sure that this class is a ball. And at the end, it spits out a Boolean, true or false. So we can go ahead and drag this out, type in branch to get a branch node. And I will plug this in between the overlap event and the door opening event. Make sure it's true. So now this event will only reach the end if it is a ball. I'm gonna let compile, save. And then because I'm not gonna need that ball anymore at the end of this, I'm gonna drag out from the end here and add a new node, destroy actor. And by default, it will destroy itself. So I need to specify a specific target other than itself. Otherwise, the pipe itself will disappear. So instead, I'm going to grab this other actor reference, plug it into here. And it's getting a little bit messy seeing this thread go through these nodes here. So I'm going to double click the thread right in the middle to add a reroute node, which is just a little point you can use to reorganize your threads, because it can get a little messy with all these strings going everywhere. That's all we need to do with the pipe for now. There's one thing I'll need to go back and do, but we can move on to the ball for now. I'm going to go ahead, open up the ball, and we're just going to add a sphere component. Just like we were adding a cube earlier, this is just another mesh. And I know this is going to be pretty big. So right away in the details panel, I'm going to go ahead and set a new scale for this. Let's say this is 0.3. And then I'm going to give it a new material. All right, made a material ahead of time, called it gold. And then further down in the details panel, we need to set simulate physics to true. That means whenever this is in the scene, it will be affected by gravity and it'll bounce off of things, it'll have collisions, just like you'd expect a real physical object to have. And then we want to be able to pick this up. So I'm going to go back here to add, and I'm going to type grab to find this grab component. Now in the template, this is a custom component called C grab component. It just adds some extra functionality, but Unreal also has a default grab component just called grab component. So if you're using the template, go ahead and use the C grab component because it has some extra stuff. One of the most straightforward things it adds is haptic feedback by default. So using this dropdown, we just go ahead and select a grab haptic effect. And all it means is when you grab this ball, your controller will vibrate a little bit. So with that, that's all we need to do with the ball. We can go ahead and test this out now if we drag one into the scene. I'm going to save. I'm going to drag one, I'm going to put it in the scene, and then I'm going to hop into VR. I'm in, go reach down, grab the ball, and then I'm going to drop it in. But wait, there's a problem. So by default, when you import a mesh into Unreal, a boundary is drawn around the mesh that is basically like a simple box or cylinder or whatever to act as sort of the collision model for this mesh. So whenever something is supposed to bounce into the mesh, it doesn't actually hit the pipe itself. It hits the boundary around it. This is put in place for performance reasons because it would cause a lot of issues if every object in a scene was working off of detailed collisions. So basically, if every polygon could be collided with, it would cause massive performance issues. However, that causes a problem for us when we want to drop that ball into this pipe, because we don't want the boundary of this to interfere with the ball dropping in. So we need to go into the settings of this pipe and enable complex collision, which is basically a much more detailed boundary for other things like that ball to collide into. So I'm going to find my pipe model, which I have here in my models folder. I'm just going to double click it, open it here. And here we can see all the settings for this, just this model in particular. If I wanted to, I could even set a default material by going here and then selecting something from the dropdown. I'm not going to bother with that. I want to go down here to collision. From here, you'll find a category called collision complexity. And from here, we can select from the dropdown things like use simple collision as complex or use complex collision as simple. Now, to show what I'm talking about this collision stuff, I'm going to go over here to show. And I'm going to check simple collision. And you can see all these green lines are the boundaries that make up this pipe. So of course we're never going to get a ball to drop in here because the boundary drawn around the pipe won't allow it. But if I turn on show complex collision, we can see that each of these polygons that makes up the pipe could also be used as collision. So I'm going to go back over here to collision complexity, and I'm going to tell this to use the complex collision as the simple collision, which basically means it's going to take all those polygons and it's going to replace that boundary it made around the pipe with the polygons instead. And then I'm going to go up here to save to lock in those changes, and I'll just close this because I won't need that again. All right, and now let's test. Back in. Grab the ball, and I can drop it in. And just like that, the door opens, and I can leave. So that's working. And now in my blueprints, I'm going to make the spawner for the ball. So like before, I'm going to add a mesh. Call this pipe. I find my pipe model. This time I'm going to give it a different material. It's called pipe. It's a lot more boring. You're not really supposed to look at this pipe as much as the other one. And this one I want to be upside down. So I'm going to flip it around 180 degrees. And then I want to add a scene component to this. And this is going to be my spawn point for the ball because I want to specify exactly where in the pipe it's going to appear. So I'm going to call this spawn point. And then looking at it from the inside, I'm just going to drag it down. And you want to make sure that you drag it far enough down so that it doesn't spawn in the base of the pipe and get stuck. So there needs to be plenty of space for this ball. Compile, and I'm going to go to the event graph. Get rid of these events. Now, for this blueprint, we want to use a different blueprint interface than the one we created. Because I want to take advantage of this button, and the template has its own interface for these button interactions. So I'm going to go to class settings, and under the dropdown for implementing, I'm going to type in player interactions. I'm going to hit compile. And you can see over here on the left, when I implemented that interface, all the functions that come with appeared right here. So I can double click activate and add it to my event graph without having to search for it. And so I know already that when I press this button, it will send the activate event to whatever object I specify. Then from here, I'm going to drag off the pin. And I want to spawn actor from class. And this does exactly what it says. It will create an object of whatever blueprint class we specify. So I'm going to say ball. And then remember we talked about with the transform variable, that's just a compound of 3 compound variables. So I'm going to split this struct bin. And what I want is the location. So I'm going to grab a reference to my spawn point and pull up from here, and I'm going to type get location. Specifically, I want the world location. And I'm going to grab this vector and put it here in the transform. Then all I need to do is compile. And now with that set up, I'm going to drag my spawn pipe into the world. like that. And I want to line up with this pipe so that it falls directly onto it and it catches the ball so it doesn't go rolling around the floor. So I'm going to make note of the location of this pipe. On the X and Y, it's at -100 and +150. So I'm going to type the same thing here. -100, 150. And now they're perfectly lined up. And now, just like with the gold pipe and the door, I want to set up the button to have a reference to this pipe. So I'm going to select the button, and right here, actor to activate, I can use the eyedropper to select the spawner, and now it references the spawner. All right, and with that, we should be good to go. So I'm going to jump into VR. All right. So I'm in. I'm going to go over here, give the button a push. It gives me a ball. Grab the ball, go over here to this spawner, go over to this pipe, drop it in, and the door opens. I can leave. Now, one more thing. I did leave another button out here. So I would like to go back to my door and just real quick add the functionality to close this door with this button. So I'm back in my door blueprint. The first thing I need to do is I need to implement that same blueprint interface that I did just a minute ago for the button. So I'm going to go to class settings, add player interactions. I'm going to double click activate to add it in. And what I wanted to do is I wanted to link into this series of events. But before that, I needed to change my open variable to be the opposite of whatever it is when the event fires. So I'm going to go over here, set open, and I also want to get a reference to open. We have get and set, and I want to set this to be whatever the opposite of itself is. So to do that, I'm going to drag off from my reference here, and I'm going to get a not Boolean. And all this node does is take an input of true or false and spit out the reverse. So if open is true, this will be false. If this is false, this will be true. And I want to plug it in to the set node. So what that does is it basically created a flip-flop. So that will happen first. And then I can plug this into my delay node, and it will follow through with all of the same functions as before, but while executing this little flip-flop beforehand. I'm going to hit compile and save. And then finally, I'm going to select this button, get a reference to the door. And then we can test it out. And then I can go ahead and press the button, close the door, press it again to open it, and just keep doing this. And there you have it. Obviously, this isn't really a puzzle in the sense that it requires a lot of thinking. To do that, I would need to add some more design to this to maybe hide the button or add some distance between the spawner and the gold pipe or something of the sort. But I just wanted to show you guys how to make these building blocks for a puzzle to make a little escape room experience. This is absolutely the tip of the iceberg of programming. There's so much more to explore. It's a whole field in its own, but I hope this was a good introduction to the concepts and sort of the workflow of programming in Unreal. So with that, I wish you luck, and I hope you have a good day.